Hey guys, so in this video we're going to go over how to turn an integer that's in binary notation into hexadecimal notation. So here we have a binary number. What you're going to do is split these numbers, these ones and zeros, into groups of 4. But you have to start from the right and go to the left. You can't start from the left to the right. You must go from right to left. What do I mean by that? Well, you would count 1, 2, 3, 4, and then draw a line. And then 1, 2, 3, 4, and then draw a line. And then 1, 2, 3, 4, and then draw a line. And here, as you can see, these are all in groups of 4, except this guy. Well, if this group is missing some numbers, you put a 0 to make up for the missing fourth piece, or fourth number, or third number, or second number, or whatever. So now we have groups of 4. 1, 0, 0, 1, 0, 1, 0, 1, 1, 0, 1, 1, and 0, 0, 1, 0. So what you're going to do now is take each part. So I'm going to start from this side. So 0, 1, 0, 0, and write them into a list. The next one is 1, 1, 0, 1, and then 1, 0, 1, 0, and then 1, 0, 0, 1. This is in base 2. So now what you're going to do is at the top of this list, you're going to write, or you're going to put these little position bars, and you're going to write 2 to the 0th power, 2 to the 1st power, 2 to the 2nd power, and 2 to the 3rd power. You're going to convert all of these binary numbers into decimal numbers. Let's start with the first one. So 0, 1, 0, 0 in binary notation to decimal notation means I have to take 2 to the 2nd power times 1 plus a bunch of zeros, which means it equals 4 because 2 to the 2nd is 4, 4 times 1 is 4, 4 plus 0 plus 0 plus 0 is 4. So this is equal to 4 in base 10. Now let's look at this guy. 1 times 2 to the 0th power is 1. 1 plus 0 is 1. 1 plus 1 times 2 to the 2nd power is 1 plus 4 is 5. And then 5 plus 1 times 2 to the 3rd power, 2 to the 3rd power is 8. So 8 plus 5 is 13. So this is equal to 13. And then we look at the next guy. So 0 times 2 to the 0th is 0. 0 plus 1 times 2 is 2. 2 plus 0 times 2 to the 2nd power is 2. 2 plus 1 times 2 to the 3rd power is 2 plus 8. And 8 plus 2 is 10. So this is equal to 10. And then 1 times 2 to the 0th power is 1. 1 plus 0 times 2 to the 4th power is 1 plus 0. And then that equals 1. And then 1 plus 0 again is equal to 1. And then 1 plus 1 times 2 to the 3rd power is 1 plus 8, which is 9. And the reason why I skipped my explanation of the zeros is because whenever you see a 0, you can just say, oh, I know that 0 times any number is 0, so I could just say 1 times 2 to the 0th power is 1 plus 0 plus 0 equals 1, plus 1 times 2 to the 3rd power is 8, which is 9. If you need more help or guidance on turning binary numbers into decimal numbers, I have a whole video on that I walk you guys through it more step by step instead of the way I'm doing it right now. I'm assuming you guys have experience in turning binary numbers into decimal numbers, so if you don't, please check the video in the description. Now that we have the 4 bits turned into decimal notation, we then turn the decimal notation into hexadecimal notation. So remember, the hexadecimal have letters in them for the values in decimal form 10 through 15. So 4 stays the same. 13 is different. 13 in decimal form turned into hexadecimal form is D. And then 10 in decimal form turned into hexadecimal form is A. and 9 in decimal form is 9 in hexadecimal form. So now, what you're going to do is from top to bottom, left to right, you're going to write 4DA9 subscript 16, and voila. So this right here is the hexadecimal notation of this binary number. Okay, let's do another one. So convert the integer from binary to hexadecimal notation. So we are given a binary number, and the first thing we're going to do if we want to turn this binary number into a hexadecimal number is we have to split the ones and zeros into groups of 4, starting from right to left. So 1, 2, 3, 4, split, 1, 2, 3, 4. There we go. So now what we have to do is we have to write the 0, 0, 1, 0 down and the 1, 1, 1, 0 down. Now we have to turn these binary numbers into decimal numbers. So what we're going to do is at the top, I'm going to write 2 to the 0th, 2 to the 1st, 2 to the 2nd, 2 to the 3rd. 0 plus 1 times 2 to the 1st power is 2, plus 0 is 2, plus 0 is 2, so that's 2. Now for this number, we see that 0 times 2 to the 0th power is 0. 0 plus 1 times 2 to the 1st power is 2. 2 plus 1 times 2 to the 2nd power is 2 plus 4. 2 plus 4, which is 6. Then 6 plus 2 to the 3rd times 1 is 6 plus 8. And 6 plus 8 is 14, so that's 14. And then we're going to turn these decimal numbers into hexadecimal numbers using this chart. So 2 stays the same, but 14 is equal to E16. And then from left to right, top to bottom, we write 2 and then E16. So this right here is the hexadecimal form of this binary number. Okay, so if your teacher is really nice, they might let you use this chart. So they might let you use a chart that has the decimal form, the hexadecimal form, and the 4-bit binary equivalent of all of these numbers. So let's use this chart to solve the very last question. So convert the integer from binary to hexadecimal notation. So we're going to split this number into 4-bit pieces. That step does not change. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And I'm going to write it out just so I could see it bigger. So let's see. So 1011. 1011 is B. 0111 is equal to 7. 1100 is equal to C. 0101 is equal to 5. So now all you have to do is just write B from top to bottom, left to right, B 7, C 5, 16. So this right here is the hexadecimal notation of this binary number.